Hello students, this is Attri. Today we will discuss about equipotential surface. So students, what is a equipotential surface? A surface which has the same potential throughout its surface or throughout the surface area is called an equipotential surface. For example, let us consider a charged body which have a positive charge, or let us consider a single charge, or let us consider a dipole. What are the equipotentials for the charged bodies? As the charge is positive, the electric field is directed outward to the body. Hence, the according to equipotential surface, a surface which has same potential, and potential is depend on 4 pi epsilon naught r, means potential is directly depend on charge and inversely depend on r. So I will consider a point which are only influence of charge q, means influence of the same charge q and at a distance r. So each point that at a distance of r, and r is in influence of the charge body q, we will make a imaginary surface, that is sphere. Means to say that for this charge also, point throughout the charge which are separated by distance r and influence of the same charge q will make similar Gaussian surface which is a sphere. And for the dipole, in case of dipole, the electric field emerges from positive and submerged to negative. Hence, if we have to consider points which are equidistant, all points which are equidistant to both of the charge and same influence of both of the charge are experienced by that points, will make a Gaussian surface like this. This is Gaussian surface or equipotential surface. Both surfaces are similar properties. So equipotential surface, from these examples we can define our equipotential surface as the potential having same potential. The potential, the surface having same potential throughout its aerial part is called equipotential surface. Now students, what are the properties of equipotential surface? How can we determine an equipotential surface for a charged body? Let us consider a charged body, another charged body, a line charge, uniformly charged body. So what is the Gaussian surface for this charge? A cylindrical surface. This is the Gaussian surface, and this is also equipotential surface around the charged body. So in similar manner we can write properties, some properties of equipotential surface. The first property is work done to move a charge from one point to another point on a equipotential surface will always zero. Work done to move a charge from one point to another on equipotential surface will be 0. we can prove this statement also, as by definition of potential, it is work done. Let us consider a single charge. Let us consider a single charge, which has a Gaussian surface, spherical in nature. Let us consider 2 points, VA and VB, which are at r distance from the charge, and both are a radius of the Gaussian surface, or we can say that equipotential surface. So work done from A to B is equal to small change in potential difference, that is VB minus VA, and as is clear from the figure that VA and VB are both point are in influence of same charge and are separated by equal distance r. Hence VB and VA both are equal. That's why the work done from A to B is equal to 0. The second property is electric field. As similar to Gaussian surface, equipotential surface also has normal electric field throughout its aerial part. Electric field will always perpendicular to the equipotential surface. We can prove this also, as work done is equal to 0, then work done by definition force dot displacement is equal to 0. Force cannot be 0 according to Coulomb's law. dr displacement, as from figure it is clear that dr is also not equal to 0, but after removing dr it will take a cos theta. F not equal to 0, dr not equal to 0, but cos theta can be 0 when at theta is equal to 90 degree. Hence it is proved that electric field throughout the region of equipotential surface always perpendicular to the surface. Next, no two equipotential surface can intersect each other. No two equipotential surface can never be intersect each other, because if they do so, let us consider equipotential surface of this point charge 2 coulomb and another equipotential surface of 4 coulomb will intersect. Then at intersecting point, what will happen? These 2 points of intersection will show potential of 2 coulomb and 4 coulomb. Means to say that these 2 points have 2 dissimilar potential, which is not possible for a condition of equipotential surface, as equipotential surface is a surface which having same potential, means single potential. That's why they cannot intersect each other. Means solution, if they do so, this is our conceptual question, that no two equipotential surface can intersect each other. Why? Explain. If they do so, then at intersecting point there may be two potentials shown by a single point, that is intersecting point, which is not possible. That's why equipotential surface cannot be intersect each other. One more property is there, which is Therefore, more equipotential surfaces for a single charged body will be near to each other at a region of higher electric field, and which is farther to each other at a region of low electric field. Means, let us consider a charged body which has large value of electric field near it and small value of electric field far away at farther point. Then if we have to draw equipotential surface at its near point, then they will be closer to each other. But if we will make equipotential surface at a far distance, then they will be farther to each other. So it is our fourth property that equipotential surface will be closer at a region of higher electric field, and it will be farther for the region of lighter electric field or smaller electric field. So students, these are the properties of equipotential surface. If you have any doubt, then put it on the comment section. Thank you for watching.